Whoa, did I just wreck the chat? Might have just wrecked the chat. Oh wait, no, this is a different one. Okay. No. All right. Good morning. Happy Saturday. Welcome. Thank you for watching if you're watching. Can turn this off. And I think we're ready to switch this up here. Let's see. All right. Welcome. Hello. Welcome. Again, thanks for everybody watching. Quick introduction. If you're new, my name is Tim. I go by Foamy Guy on GitHub and Discord. I typically stream at this time each week, working on stuff related to CircuitPython. If you are new and you don't know what CircuitPython is, you can learn more at the main website for it here, circuitpython.org. Basically, this is a version of Python that runs on tiny computers called microcontrollers. There's a bunch of pictures of them here. These things come in all different shapes and sizes. If you choose to use CircuitPython with them, the most typical way that it works is you plug it into your computer with a USB cable. It shows up like a little thumb drive, basically a little drive on your computer. On that drive, there is a Python code file, and you can open that in whatever text editor you want, edit it, and save it. And when you save it, the microcontroller, the little computer on the device here, will actually notice that you've modified the file and will reset itself and execute the new version. So that's kind of the high-level look at what CircuitPython is. Like I said, there are all different shapes and sizes and capabilities for these microcontrollers. Some of them are sort of more like fully featured little devices. Some of them are just completely bare circuit boards with pins that you can hook up whatever you want to, and everything in between. There are 536 currently that support CircuitPython. All these devices can also be programmed in different ways, but CircuitPython is the one that we deal with here on this stream. As always, huge thanks, of course, to Adafruit. Adafruit is a hardware and software company based out of New York. They're the ones who are paying the folks to work on CircuitPython. So anyone is allowed to use CircuitPython. You can use it in your own products. You can use it in projects. It's all open source. You can go and look at the source code. You can modify it to do whatever you want. You don't have to pay for a license. You don't have to do any of that. You're allowed to use it in whatever way you want, essentially. And the way that works is Adafruit, hardware and software company, again, selling hardware based out of New York. You can place orders online and they'll ship it to you. They're funding CircuitPython by paying the team who's working on it. So there's a team of folks who work on the project full-time and are paid by Adafruit to do so. And there are some folks like me paid to work on it part-time. And so thanks, of course, to them. And if you want to help support CircuitPython, one of the easiest ways you can do it is just purchase hardware from Adafruit. Oh, that's pretty cool looking. We got some drum machine action going on there. Haven't seen that on the front page before. Pretty sweet looking setup. All right, so yeah, you can get yourself some of the microcontrollers there. You can also get all sorts of stuff that you can hook up and do with your microcontrollers. And they also have the Learn, half of the site, essentially, the Learn Guide system, which has got all sorts of projects and guides that you can do with your microcontroller and with all sorts of other bits and bobs and things. So head over there, check it out. Thank you to everyone who does. And with that, we'll jump in. The microcontroller I have today here to work on is this PyPortal Titano, which needs to be plugged in before it will do anything. And what I have on it is an interesting hollow circle. The reason it's interesting is because it's a Vectorio circle. but Vectorio circles don't actually support this idea of having a hollow inside and having only a stroke or only an outline. That's actually not a thing that Vectorio supports, but I was kind of hacking around on it yesterday a bit while I was watching the deep dive and kind of hacked this together to make it work. And I was surprised a bit at how easy it was. We may eventually try to PR it. I don't know for sure if it's a thing that will be wanted, because there is, of course, the display shapes library. Which I would like to find on GitHub, please. This one is a Python layer, a Python level library for making shapes, and it does have a circle shape, and it does also support outlines, although I think it calls them stroke. And the other thing is this also supports different colors. Actually, it does call it outline. Okay. It supports different colors. So you can set one color for the fill color, you can set one color for the outline color, which is a thing that you cannot do with Vectorio, even with this hacked together one, currently. Although, I mean, it's not an impossibility. It would just mean we need to store a separate color index, basically, on the object. But this is unrelated to what I really want to start working on, so I'm actually gonna somehow try to get this out of here and into somewhere else. Let me copy this and make a new, just like, scratch file, basically. Let's to see. And then in this one, for now, I'm just going to revert all of this stuff so that it goes back to being normal Vectorio circle, which actually was the only changes in this file, so that could have been a lot easier. Could have just rolled back the file, but that's all right. I thought there were other changes in here. Yeah, let's make sure that works. And then after this builds and works and doesn't crash and is back to normal, then we'll get into what I really want to start working on, which is some more of the intersection stuff inside of Vectorio, which I'll mention while we're waiting on this. If you're interested in the background on, there are a few older, I mean older as in the last couple of weeks, live stream videos over on YouTube, which you can watch if you're interested in kind of the precursor to the intersection stuff that we'll get into here in a minute. All right, we got a firmware. It's a good start. Let's go to bootloader. I forgot the Titano is kind of bad on the glare. Okay, yeah, looks like we're back to normal there. That's good. All right, so when we left off with intersection, the last thing I was working on was line contains point. And in order to make line contains point, we need to calculate the distance between 2 points. And in fact, we need to do that at least twice, maybe 3 times. We need to so line contains point. We need to calculate the distance between the point and each end of the line. So that's 2 distances we need to know. And then we need a third distance, which is actually the distance between like the distance of the line, the length of the line, so the distance between the 2 points that make up the line. We need to have all 3 of those distances. When I was working on this last, if you do go back and watch the prior stream, I was trying to do it with this math.dist function, which exists now, was added recently, but this is not, the conclusion I came to was that this is not very possible, not very easy, certainly. So it is all commented out here, and it will eventually get deleted. And instead, what we're going to do is, I think, actually maybe make... So at the end of the last video, I was talking about, like... These are all called common how. Is that like a thing? Do we have to be called that? At the end of the last video, I was talking about copying the bits we need, pasting them in multiple times, which we could do. But we could also theoretically just make our own little function inside of here. Let's see why not, right? Float. I don't think we would want to call it this, because I'm pretty sure that implies that it's going to be called from shared bindings, which is not going to happen. So this is just a function that will exist inside of shared module only. It will never get called from Python land, although it will do the same thing as math.dist, which could get called from there. So I'm going to call this measure distance. And we're just going to go x1, y1, x2, y2. And so we will make it simpler, actually, than this, because we're not going to bother with... Well, we're not going to take in tuples or lists. In CPython, this one can actually take in more values. In CircuitPython, it can't, although it could be added in the future to be able to do so. But in this one, I'm not even going to bother with lists or tuples or anything. We're just going to hard code 2 points, because that's exactly what I need. Measure the distance between 2 points. And that will be basically just... get the dist x, get the dist y, and then we are going to put them through this thing, pretty much. So we need float. Actually, so, well, we can't just, this is not Python. These need, like, things, right? We want, I think these can just be ints. In my case, like, the math one can do floats, but again, here, we're in Vectorio, which is dealing with pixels. So, like, these are always going to be whole numbers. There's not half a pixel, really, in the concept of Vectorio, at least. So, float, measure distance. We are going to get, we're going to end up with a float at the end, because we square root it, but... in which case, these can be also just ints, I think, right? Dist x is going to be x1 minus x2. Does it matter what order we do that in? So here we did EQ. All right, because we have P and Q are the list names. P and X, P and QXN, yeah. Okay, I don't think the order matters that much, because it's basically, I mean, P comes first and then Q comes next. I don't think it really matters that much, in our case, inside of here. You can go dist y, which will be y1, y2. And then we will just return... So this is using the square root, so it is going to do that sort of slower operation, but let's get back to, is it Jeffrey Thompson. Let's go line contains point. All right, so we have the line length. We have the distance between the point and each end of the line. We'll add this in a minute. They call it buffer. What did I call it? I don't necessarily like the name buffer that much for that concept. I get it, sort of, but whatever I called it inside of here is actually what I prefer, which I called it the pad value. It's not that much better, I guess. For now, we're just going to ignore that bit, though. So then... I cannot tab? What is up with CLion, like, not letting me do hardly anything with the code? I think CLion really trips up on the CircuitPython project structure for some reason. I don't know what the problem is, but lots of stuff that works in other JetBrains IDEs just doesn't work. Even basic stuff like indenting, like I'm pressing tab here. Like, this is like notepad level editing stuff. I don't get why that would not work suddenly. Let's see, so we don't have D1, D2 yet. I'm not gonna call them that, actually. So they say line length. Yeah, Control W. So Control W is supposed to like select a word. It's not working. Kind of bothering me, so I'm gonna give it a very, very, very quick rabbit hole search here and see if anything comes up. Tab not working. Let's try it. Let's start with that. That's basic. Tab key not inserting. Key is mapped for indentation along with switching to the next parameter, which is supposed to determine intelligently. You can disable and change preferences key map next parameter. Preferences key map next parameter. What? It doesn't go to the next parameter either. Preferences. Editor. No, what was it? Preferences key map next. Key map. Where's key map? Not in the top level. Key map. Key map. Next parameter. It's just in this list. Next parameter. Disable. Move tab. Apply. No, no difference. It's the one that suits you best. We'll try this and then I'll just get back to coding, but preferences editor code style. Editor code style. Tabs and spaces. Language. I mean, one thing I noticed is there it doesn't say C here. I don't know. C's not listed. Technically, we're in a C file. I don't know if that means it falls into here. I don't know if that means it goes under this. I don't think so. This is like make thing, I'm pretty sure, but I don't know. I don't know if it ends up under here. In any case, it's not really working. I almost wonder, is it even worth, like, is there anything that CLion does that PyCharm doesn't in this context? I can't, like, control click either. How about measure distance? That's declared in the same file. Can I control? Nope, can't click that either. Cannot find declaration to go to. It's literally right there. Do you have to put this above? Is there no hoisting? I don't know. No, still doesn't work. I don't know. Maybe I'll switch back. Maybe it's like CLion doesn't seem to really do much good for this project, at least. Okay, so we have line distance. We would like to get distance from one end to the point. From one end to the point. So from one end to the point, and then from the other end to the point. Okay. This is actually underscore. And then we don't have a buffer. So I'm just gonna put that on 0 for now. Oh, these are all gonna need this. These will be floats, though. All of these are going to be floats because they come out of that function. Okay. Yeah, let's test it without first and see how it goes. I don't know for sure if it's going to be very easy to test or not, but... Line contains point. Not used. Like all of these are broken. No previous prototype. Missing some more semicolons. That probably wrecked a bunch of other things. Let's try. I don't know where that opened, but whatever. Okay, no previous, we still have that thing. I'm trying to define it right here, though. Guess you can't do that. Yeah, you can't do that. You need to put it here. Let's float, measure, distance. Are they in? So it's not those though, because this is only in, this one's like internal basically. These are actually ints. Okay, we need to import that or whatever. I don't know where it comes from though. I don't want the generic answer though. I'm actually looking for definitely the square root f. Doesn't seem like. I mean, I know it's just to import something. Math h. Math h. I wonder how can it make the distinction between math h, the C concept, which seems to exist, versus math to CircuitPython. I guess math to CircuitPython one would be like math/init. Yeah, because I mean, in fact, that's the file we're in here too, so I guess that makes sense. Well, okay. Somebody was here before me, apparently. Okay, but the truth is, well, I guess we could test it on this device. Yeah, let's test it on this device. We need to burn it first. Flash it. No. Oh yeah, with this thing again. Okay, escape key works. I gotta remember that, escape key. Don't actually have a rect. And actually, this is old. Let's see if I can do this without avalanching everything off of my desk. Okay, I'm gonna get rid of the driving the shape around. In fact, we really only just need pass and nothing else in here. I mean, we could keep this so it's not revving as hard as it possibly can, but okay, so we have two rectangles. They are called static rectangle and moving rectangle. I'm not going to bother changing the name, but they're both going to be static in this case. We're gonna say if Vectorio line contains point which accepts the line first and then the point. So the line we're going to use is the top line of the static rect, which will be xy and then x plus width, y plus height. And then we'll use the top left point of the moving rect. And if that's true, then we'll set the moving rect to red or whatever the other color is. I think green, actually. And when we run it the first time, it will not be touching. The point will not contain, or the line will not contain the point. Gotta get TO. Okay. Moving one is in the top left corner almost. Static one is down and to the right a bit over there. Moving one is red. It's not actually going to move either, but I'm going to keep calling it that because that's what the variable is named. What we're going to do is just move it to be at same x as the other one. 75. So we're going to say anywhere between 75 and 75 plus 80. So let's just call it like 100. And then the y will be on 75. So the small one's going to be basically layered on top of the big one with the top left corner touching the top line of that. And theoretically, it should turn it colors green, but that didn't work. Oh, this is wrong. This is a diagonal line down the center of the rectangle. It's not what we want. We want y to stay the same. Nice. Okay. I am just actually going to move over to the other device, though, where we will be able to copy the code. Can I copy the code still? No. Okay, I'm going to plug it back in so I can copy the code. All right, so we want to use this other if statement. Actually, let's take that whole thing. Need to make the build for this device. Maroni ecosystem? Question mark? A slow build for Raspberry Pi. And then here is where we basically get to the reason for that buffer or pad value, is because it turns out a line is a really, really thin concept. In our case, we're working with pixels, so our line is effectively 1 pixel long, or 1 pixel tall, I should say. We can see that it's working, but it is really, really difficult to get it to count as an actual, positive. And that is where the buffer, what Jeffrey Thompson calls the buffer, and what I like to call the pad value. Now, so we need to come back here, and all this stuff takes ints. I need to find a thing that can take a float. Would it just be float underscore t? Or object t, because it could be none? Oh, no. Is there any floating in here? No. Oh, bitmap tools. MP float t. And that's in roto zoom. So it basically angle. Yeah, we want to do basically this. I'm going to call it padding instead. Arg. Would assume that that's going to be like that. Oh, actually we should totally do it this way. And we can even keep that comment because that's exactly what we're going to do. So yeah, keyword only. You have to pass it if you want it. It will be padding. I'm just going to leave it at that, actually. All right, what is it? It was MP float T? Hey, wait a minute. We're in shared bindings. I wonder, that probably shouldn't be here. I don't know if it works if it's here, though. Because that's including that one. Okay. Well, unfortunately, I'm also still like halfway between adding this, so we can't just run and see if that breaks anything. That was right for this. Actually, we don't have this side. Roto zoom. Yeah, MP float T scale. And then scale. Okay, so it's gonna, and when it gets to here, it's always gonna have a value that's not none, because inside shared bindings, we set it to 0 if it was none. So when we get to here, we can assume it will have a value, which means we can just get rid of this and we can go padding here, and then I think the rest of this will work. And now it will have this sort of forgiveness value, fudge factor type thing. Okay, does it build? I'm gonna guess no, but we'll see. I wonder if we actually need to import the shared module one. Maybe that will just like exist because it's the H file that belongs with this C file. Because like, I don't know what these are for. So I guess that's a good place to start, but I would assume that these get used from inside of here somewhere. And maybe not, actually. I don't know. All right, we did get a build. Can we take that out, or? No. Okay, well, fair enough. All right. So right now it should still do the exact same thing as last time, which is basically we have that padding on 0. And yeah, I can see it turning green there for a split second. I probably won't be able to line it up again, but yeah, that was about, I think that's probably as close as I've gotten me. I definitely see it switching though, so I think it's working. But here's what we could go and do now is change this pad value. This is Python code. I think I'm going to leave it on 0. I'm going to leave it on 0, or should we leave it on 0.1? So in the example here, he just hard codes it to 0.1. I mean, it's a variable. You could change the variable, I guess, but he didn't bother to make it an argument. I think I like it as an argument, and I guess we'll leave it on 0. I think it makes sense to default to 0 so that you get literal values, you know. Oftentimes, if you're using it for this purpose of like pixels and displays, you're probably going to want a little bit of a padding. I think we're ready to finally ixnay on all of that. This actually turned out not so bad. I'm glad I am glad we put this in its own function rather than having this 3 times here, so it is a bit weird that we now have this implemented in 2 places. Maybe the math could be separated out into shared module, but the thing is, it's not like that today. There is no math in shared module today, so that's a bit of a more exotic change. Then there would be an easy to call function here that we could use instead of rewriting it, but it's not the way it is for now. Let's just, so yeah, we don't really need to do anything here. We can just get back to our code and give it some padding. So right now we'd be on 0, so let's just try 0.1. Okay, that was not the comma. Padding equals 0.1. Restart. Oh, this is going to be on TTY 0 now. Okay, I mean, maybe, yeah, it's like a little bit bigger, it's a little bit easier to hit, it's like staying green for a little bit longer, but, you know, it's not that easy. Let's see what 2 is like. Need to reset. Yeah. Now we've got a zone that's actually relatively easy to hit and land on. If we gave it 1 more, it would be Probably pretty hard to overshoot, I'm guessing. Let's see. Yeah. Okay, so that just gives you like some fudge factor there, so you can be outside the line a little bit and it still counts. Although whatever I said about being hard to overshoot is obviously wrong. I think I can tell that we are getting further away each time. Maybe we try like something even bigger. Yeah, it's definitely getting bigger each time. That seems like it's working. Okay, so we now have line contains point, rectangle contains point, and circle contains point. All three of those have been tested. The circle and the rectangle were tested last time. So I think... Yeah. So for polygon circle, we need line circle, which we have. So we have vertices representing the polygon. We have this values representing the circle. We're pretty much looping over all the vertices and then considering the line between each vertice. So we're pretty much saying if the circle is intersecting with any of the lines that make up the outside of the polygon, then we consider it true. And then there is actually this as well, polygon point. And the way that they've implemented it here, they're actually kind of like doing this check on each of the edges and the circle, and then they're saying like, don't use this part unless you really need it. And if we were to follow through and figure out inside a polygon point, it says only if you need it, but it is effectively going through the loop of all the points again. This is just going through that full list of vertices again. So if we did implement it in the way that they have here, we would end up looping twice in any case where the circle was fully enclosed inside the polygon, which is why this polygon's going back to blue here, is because they've actually disabled that portion of the code. So any case where we're fully enclosed, we would have to loop twice. And any case where we're fully outside, we would end up looping twice through all the vertices. But I actually implemented this over here, I think. Yeah, polygon circle intersects. I actually just refactored it to loop once and to have a test contains Boolean, and then inside of the one loop, I just have if test contains is true, then do that other check, which was all of this stuff here, which I'm not going to necessarily say that I fully understand, but I did successfully copy it into Python code. And this seems to work, so we could pretty much model our C function off of this. And I guess we could make polygon. I mean, should we make... I guess we should. I mean, if we're going to have circle contains point and we're going to have rectangle contains point, it does feel a little bit awkward to just skip polygon contains point. But if we implement it in the same way as I did the Python version, then we won't strictly need polygon contains point. Whereas we do strictly need circle contains point and rectangle contains point if we implement it in the way that I did in Python. I think let's worry about polygon point later. Let's start with bool. So yeah, I don't know that the order really matters. I'm just gonna go, I guess. Also, I started with circle here. Does that matter? I don't know if that matters. We're just gonna go. Actually, we are gonna put it. Yeah, actually, we are gonna do it the other way because I want to take the points first. Which doesn't really matter. Intersect. Let's call this. So we need find some way to take a list of points. List of points, and then we have the circle stuff, which is these. What do we need next? We need more shared binding stuff. What do I want to copy here? I guess let's copy circle rectangle to start with. I'm gonna bring it on down. Ah, this is rectangle, rectangle. Okay. Polygon circle intersects, get rid of the rectangle, and then we will have the points. Just, it's probably not what we want, really. Well, that's the one in this, though, is it? No. It's the one in here, but it's not, it's in multi-line. Get rid of our rect stuff. And then we want arg points. Actually, maybe we should use points list. But it calls it points here. It is actually points list here. Let's just say points here. I mean, I guess I'm inclined to do it the exact same way, pretty much, so. Rid of all the rectangle stuff. Add the polygon points, which I'll just get from here. Ooh. Oh, that's what these are. This one. I don't know. Why are those pink over there? Hey, wait a minute. If these are pink... Oh, the tab works. Look at that. On the control click too. Okay, so these ones where there's like almost no highlighting, like there's orange and white, but that's it. Well, and gray, but that's it. Whereas this one, it recognizes a lot of this stuff. It recognizes some of this stuff because it also just stops like halfway down, then starts again, and gets exactly one here, which is interesting. I don't know. I mean, I guess all the args and all the MPs are pink on this file. I don't know why. What would be the difference though? Like, why would it have managed to get to that file and not this one? Not sure. Anyway, doesn't matter that much. We should make this match though, right? This is required object. Did this QString points list or just points? Okay, just points. keep alt-tabbing, but that's not really what I want. Okay, so points list, arg validate type, arg points list, object type list, qstring points. And then that is what gets passed to Polygon construct. Okay, we can click through, but not. So is it shared? But I mean, I'm in shared bindings there too. So I don't know. Clobber points list. We should probably reuse this. Is W? Control W? No, Control W still doesn't work. Okay, so Polygon construct. Just sets point list. So like. Okay. Oh, we're not going to be able to reuse this because this takes a self. I mean, is the primary purpose of this so that we can pass lists or tuples? I mean, I see it's doing some other validation too. But the primary purpose just tuples? It's doing some validation here as well. I don't really know what. I mean, short min, short max. I don't know what those are. Oh, short, probably like min and max of the short, like value, like max int. Yeah, okay. This is a really weird way that it works. I guess it's because of the way it's extending vector shape. I don't really know how to get those values out of there and use them. These are all in boundary fill. So presumably that's going to return true, or I mean that's going to return whether or not this is tuples or ints. Okay, so we know this is the points. Well, we can check the H here, right? Do we need to specify those, or I think we just have ints? No, those ints. Okay. I think we can treat those like ints, though. Just say false for now. I don't. We've put a lot of stuff in. I don't know if we have broken anything. Let's try to make a build. Won't actually do anything, but will tell us if we have put the scaffold in place correctly. I should have committed before I added polygon. Before I started adding polygon. Looks like we forgot to delete some RHs. Let's see. I mean, I copied? Make an extra copy? Oh, didn't delete these. We have unused circle ones. Oh, we're missing a comma. Weird bindings. Do we have this twice? 341? Rectangle, rectangle? And then 107? Yeah. Okay, I copied it twice and then didn't delete it. Well, I copied it. Yeah, I copied it the first time and then didn't delete it, but then copied a different thing. Oh, yeah. We have almost reached the time of year where the sun comes in, splashes off the floor, bounces into my eye. Alright, I'll BRB while this is building. Okay. Looks like we got all the plumbing actually hooked up. Let's start nice and easy by just looping the points and see if we make it that far. Because we have this points list, which is np object t. I mean, yeah, honestly, I don't really know how to get the values out of it. Because I mean, that's like generic. Like, really, I want that to be like a list of something. Like, how do I get sure how to get values out of this? So there's get list, length, items, get list. And then from there on, it can use items I. There we go. Okay, so np int t variable name equals validate type int. Shouldn't this be in shared bindings? I mean, I guess because it's a list, it's weird. Hmm. Could we? Could we change this to take an array instead of an object, and then inside of shared bindings we would do the work to like convert it from a Python list into an array, and then we would pass that to the common how function? Here's another place where it is getting values out of a list, or well, converting the np object into a list and then also getting the values out of it. However, this one is using get array fixed n, so it's passing in 2. Actually, maybe the other one is doing that as well. But the difference is that it's got that length variable. I think, no, I must be doing a different one because it's setting the length also. Because it creates length set to 0, it creates items, and then it's object get list, or list get. Then it prints length. So I do know the math one supports lists and tuples as well. Like, I'm gathering from reading that clobber thing, maybe that if you use a tuple, it's less efficient. I mean, it still stands, I think, right? Because now we just switched the extra work from whatever the extra work involved with tuples is to the extra work involved in changing the tuple into a list first. So I think I'm leaning towards this way. So this is points list items. Oh, hold on, we don't want this one. What the other one? This one. Okay, so then we should be able to do First, we do still have the other thing to contend with, which is that inside of here we actually are going to end up with a list of lists. So items ends up being a list of lists. And then in there, it's going and doing another one of these. Tuple, so this is a point, tuple point. Our items is called this. QString point, yeah, we did that, I think. Tuple items. Then tuple, there's actually not a tuple length. Where did that come from? I just didn't copy it. I'm actually going to call this point tuple instead of tuple point. Point tuple. Because it sounds more grammatically correct in my head. And it doesn't. Items? Tuple. Length. Point list items. Okay. So now point tuple contains two numbers, MP int t probably. I never can remember this, honestly. I don't do enough. So I think %d is a number. And then I guess we're gonna need like MP get int or something. This one. Well, this one. So it's not get int, it's actually validate type, but it does return the int as well, though. We actually need two of them. And that is the point tuple. That should be 1. Then we can go x, y. I don't know. We might still need to try to get further towards C int. I'm not sure. While we're waiting on that. Actually, specifically a list of tuples. Point tuple undeclared. Tuple list. Points list? Yeah. Should be points list. Hmm. I mean, that's comparing length to 3. How come I'm allowed to compare length to 3? Unsigned int. Unsigned int t. Probably missing a semicolon. Yeah. Maybe missing a lot of semicolons. Looks like one. Point tuple under. Okay, yeah, but we were missing the semicolon. Yeah. I think we might be good this time. We'll see. Yeah, look at that. Nice. Okay. Yeah, and I grabbed a list of points. It's not fully implemented yet. This is just printing. We're gonna see if we even manage to get the values out of the list correctly or not. Oh yeah. Okay, I don't want to call the new function inside the main loop because then we'll just get spammed. I don't know those points anymore. Just gonna get a list of points. We're then gonna go print Vectorio, polygon, circle, intersects, points, circle x. So yeah, it really does not matter at all what we pass here. Module has no attribute polygon circle intersects. I think maybe we didn't add that to the thing at the end of shared bindings? This thing? Unsigned ints. I wonder if there's like a specific reason those need to be unsigned. Could it not work with -2? Didn't crash, and it printed some values. All right. Okay, so we have the x and y of our point. We technically need to actually get the x and y of the next point also. Probably can't refactor this, so I'm gonna rename this curve point tuple. Rename this to cur x and cur y. We could probably turn this off for now. And then, unfortunately, to an extent, we need to basically do all of this again. I mean, like, length, I mean... we like, our tuples should be the same length. But it does feel bad to just clobber it, I think, so... So this will make it so that when we're on the last point, it's actually going to wrap back around and get the first point as the next index. Next. Okay. I think this will get used in the error message if the value is not an int. So if they pass float or an object or something, I think makes sense to call it x, even though it's like technically doesn't have a name. It's just an index inside of a tuple inside of a list. Well, value at an index. Mm-hmm. Does it build? Got the semicolon. Nice. Yeah, nice. We have the next point, current point, and the next point for each one of those. And then on the very last one, we have the current point and the next point, which wraps back around to be the first point, which is exactly what we want. Oh dear. We need a polygon location. Yeah, because the way Vectorio polygon... Well, I mean, do we need to base it on that? Yeah, kinda, because otherwise... I mean... Think for a minute. So with Vectorio polygon, when you create it, you give it a list of points, and you give it an XY location as well. And if you give it X and Y are both 0, then your polygon will be literally in the locations of your points as they are on the display. But you could shift it basically with this. I think I'm just not going to have that inside of here, actually. So inside this Python implementation, it does have it, which does make it convenient to use with Vectorio polygons, because you could just pass in like polygon object.points and then a tuple with polygon.x, polygon.y. But I can really see the case to be made that that doesn't really belong inside of here, because that's kind of like specific to Vectorio and that idea of shifting that polygon object, like where it sits on the display. If we don't worry about that shift inside of here, it will mean that you won't be able to just pass in like vector io.polygon.points unless your polygon has an x and y of 0. If your polygon has an x and y, an x or y of anything other than 0, you would need to essentially create your own points list by looping over your polygon's points list and adding the x and y to each point to get a shifted points list, and then pass that in to this function, rather than this function accepting the shift and doing it for you, which is a little bit less convenient, granted, but does make it so that we won't need another argument here, which I think is kind of nice overall. Because like ultimately, while I have chosen to put this in Vectorio, I have also been intentionally trying to decouple it a bit from Vectorio. So like we're not taking Vectorio circles and Vectorio rectangles as objects. Instead, we're taking numbers, which are like from those objects. And that was a deliberate choice to try to decouple those a bit. And in this case, you know, we still wouldn't be taking the object, but we would be taking another argument and then adding more logic inside of here effectively for the purpose of making it more convenient. I don't know. Maybe it's worth adding. I don't know if I'm the best judge. Maybe at the end of the day, there's a better spot than Vectorio for this. But I wanted to get started, so I had to choose a place to put it. And the first iteration of it, I was actually just accepting the objects, so it was a natural fit to put here. But I kind of decided this way would make more sense ultimately. All right, so we're not going to worry about the shift. That was a long way around to get to the fact that we're just not going to worry about the shift. So our points are just literal, current point, X, current point Y. We have no shift, so we don't need to worry about that. Next point. Okay, so this is taking the literal next point out of the polygon points, which is pretty much what we have now, and then this is applying the shift, which we're not going to do. So I think we actually have everything we need. And so then that says basically if line circle intersects, the line being the line between the current point and the next point. So if the current line, essentially we're looping over the lines here. We're looping over vertices. So if the current vertice intersects with the circle, then this is going to be returning true. Circle. We're missing some still. Yeah, we have circle contains point, we have rectangle contains point, we have line contains point. Is this duplicated here too? I mean, I guess it wouldn't build, would it? Yeah. We don't have circle contains line. So we're actually not done with helper functions. But we are almost out of time, I think. Yeah, I was not reading closely enough. And I was thinking this was point circle, basically, not line circle. Whoops. Most likely, line circle is going to make use of line point, though. Or point circle, as it turns out. So for checking if a circle intersects with a line, we first check if one endpoint of the line is inside the circle, if the other endpoint of the line is inside the circle. So if either endpoint of the line is inside the circle, then they definitely intersect. Next, we need to get the closest point on the line to start. Let's get the length of the line using Pythagorean theorem. So that's our measure distance function. So get the length of the line. Then we get a value that we're calling dot. We've done vector math before. This is the same as the dot product of two vectors. This isn't familiar, no worry. Consider this a step of math that you could be glad to have to, yeah, I mean, this whole thing is a step of math. I'm glad I don't have to solve by hand, truthfully. Float dot, blah, 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 all that stuff. So that's basically, it's finding that red point. Like as we move this, it's kind of the place on the line that is closest to the circle. And it is able to get it like this. It's magic in math. Finally, we can use this equation to find, oh, excuse me, this is not actually all the way it just yet. We need to get this in order to find that red point. We get that first, and then we use that with these. That finds us the red point. Yeah, and then here, so the thing is that this will return you the closest x and y on this line as if it were infinite, right? As if it extended infinitely out this way and out this way. And so this next part here on segment is basically saying, is the point we found, is the closest x and y actually on the line that we have, the limited line that does have a specific end on each side, rather than that infinite hypothetical one. And then if that is true, we would return true. Well, if that is, I guess more specifically, if that is false, we would return false. But then finally, once we've done all of the above, we get the distance from the circle to the closest point on the line, the circle center, that would be. So another measured distance. And then if that distance is less than the radius, we know that the circle is intersecting the line. All right. That all makes sense, but I do think it is going to be left for another day. I think for now I'm going to wrap it up. So thank you to anybody who was watching this or catches the VOD in the future. Hope you all have a good rest of your day. And I should be back, I believe, at the normal time next week, 10 a.m. Central Time on Saturday. So until then, I will bid you farewell and good day. Thanks, and see you later.